In this lab, we will continue with the mobile data analysis. We will repeat the analysis using a multinomial regression and characterize an expensive mobile phone using the multinomial regression. From sklen.linear_model, import logistic regression. So now we build multinomial logistic regression. Let mobile mn equal logistic regression of multi_class equal multinomial, comma, solver equal IBFGS. We need to choose appropriate solver. Now we define the hyperparameter grid for tuning. Consider complexity related parameters. Let param grid equal calibraces. So we'll write that in the dictionary form. Max underscore iter is 500, 1000, 2000. Multi underscore class is multinomial. Solver is IBFGS. Printing param grid, we get this. Now we will get a lot of warning messages about the iteration. So let's import warnings and warnings.filter warnings, and we will ignore the warning messages. Create a multinomial regression and perform grid search. Let model equal logistic regression, open and close bracket. Let grid search equal grid search CV, bracket, model, comma, param grid, comma, scoring equal accuracy, comma, CV equal to. Grid search dot fit X train and Y train. These are the train independent and dependent variables from mobile train data. Now we get the best model and predictions. Let mobile mn equal grid search dot best underscore estimator underscore. Printing mobile mn gives logistic regression model with max underscore iter equal 2000, comma, multi underscore class equal multinomial. Then let's display these coefficients and the X train columns. So pandas dot data frame mobile mn dot coef underscore, that will be the coefficient values, and the headings will be columns equal X train dot columns. So we have these values over here. So we can see that battery power we have for 0 and 1 we have negative coefficient, and for price range, which is in factor form, 2 and 3 we have positive coefficient, and the blue is blue indicator, and for 0 and 2 levels, price range levels, we have positive coefficient, and for 1 and 3 price range levels we have negative coefficient. And let's pick another one, n cos. We have for 0 and 1 the coefficient is positive, and for 2 and 3 the coefficient is negative. So which means that the increase in the price range of increase in the number of cores for 0 and 1 price range will increase the price range, and for 2 and 3 levels the increase in number of cores will decrease the price range. Looking at the RAM, if there is increase in the RAM for price range 0 and 1, then there is a decrease in the price range, in the total price range. And if there is an increase in the price range, increase in the RAM for price range 2 and 3, then the total price range increases. And Y train head is this one. So coefficients for dual SIM, coefficients for dual SIM. Do we have dual SIM? Yeah. So what happens is that none of these columns have all the positive values. So but we have some of the columns with 3 positive coefficient and 1 negative coefficient. So let's look at those columns. So dual SIM, which has which shows the positive coefficient for price range 0, 1, 2, and for 3 is negative. So we'll take that coefficient for dual SIM and FC. So for the price range 0, 1, and 2, the coefficient is positive, and for the price range 3, the coefficient is negative. So we'll take that. And Wi-Fi. So looking at Wi-Fi, the price range 0, 1, 2 shows positive coefficient of Wi-Fi, and for price range 3 it shows negative coefficient of Wi-Fi. So we'll take Wi-Fi. So coefficients for dual SIM, FC, and Wi-Fi are strictly positive, and as these increase are nearly, because one of the coefficient is negative, nearly positive, and as these increase, and as the values of these variables increase for the positive coefficients, the price range gets higher. Bigger dual SIM, bigger face camera, more Wi-Fi increases a phone price. And multinomial regression, let M and P equal precision of mobile MN dot predict X test, and that will be the predicted dependent value, and comma Y test, and that gives this matrix here. And the precision is the diagonal numbers divided by the row totals and added, index 0.94. So compare the precision values. So displaying in array form, we get these values here. A lowest precision is obtained from a multinomial logistic regression. This means lower linear boundaries in the input space between there is lower linear boundaries in the input space between price ranges. So precision is lowest.